Hi, my name is Vahan Davudyan. I'm a physics experimentalist, and these are called unique physics concepts, how to promote the science by Vahan Davudyan, physics experimentalist, and this is my email, vahandavudyan1948@gmail.com. In fact, today I am going to talk about Daniel Bernoulli's principle, which is extremely important in our life, and it's one of the most important laws of aerodynamics. And I have some observation, and then I will show you exactly what I mean by Daniel Bernoulli's law. First of all, I would like to thank YouTube for this wonderful opportunity for us, so we can upload our theories, and then it's a great opportunity. Some other people can upload their theories, we exchange views for the new inventions, for the new technologies, for any scientific concepts. And in fact, this is the best way we can promote the science. And in fact, I call the YouTube synapse in a human's brain is connecting billions of neurons for the communication. And it's like a huge university, it's connecting everyone. I mean, how could I express my opinion if there's no YouTube? So I can upload my videos, anyone can talk, watch that. I can watch their videos, we can exchange views, and then we can learn. Like I said, I've been doing this for almost 30 years, and a physics experimentalist, and my theories are unique. I have never seen in any physics books. I have already uploaded 42 theories. All of them are substantiated by experiment. I have 30 more. I will publish them every month. I have had many lectures in physics in CU Boulder, DeVry, and Regis universities. My inspiration came from nature, animals, insects, and the sports. Many science and physics lovers or enthusiasts emailed me, and they loved my unique concept. I would like to thank them. It was great encouragement to upload more theories. I have replicated most experiments like Sir Isaac Newton, Galileo, as much as I could. My main objective is to activate sense of wonder in young generation, so they can analyze everything and come up with the answer. Based on my observation in these last 30 years in nature, I have simple experiment to demonstrate Daniel Bernoulli's principle, which is very important law in aerodynamics. Millions of travelers use this every day by flying with airplanes around the globe. And in fact, I have some posters. I can show you exactly what I mean by Daniel Bernoulli's law, and these are my observations in nature. So you can see, let me push this a little bit this way. This is a very important concept. And most of the time, these things happen in our ordinary life. And like 6 months ago, I published one which was great success. It was called 3 Theories, like 1.5 hour, how to learn laws of physics in the street. And this is one of them. At that time, I missed this one. And imagine when the huge cars like bus or 18-wheelers or bus is passing by, and then you have no idea, if you're traveling with a small car like sedan like this, you shake, you wobble a little bit, but you have no idea what is the logical analysis of it. So, like I said, because I'm a very meticulous person, I analyze this, and then I realize when the huge cars, like 18-wheelers or bus, they're passing by, they are displacing air. So what happened close to this car, which I'm traveling side by side, they're creating partial vacuum. So what happened, because these are like 40 tons, maybe like 2,000 kilograms. So I will accelerate toward those. So because I'm driving like 100 kilometers, they're driving 100 kilometers, but I wobble a little bit. So in fact, the way they displace this air is directly proportional. The faster they go, the more wobble you get, the more your car is shaken. So I call this corridor of displacement for the air. So that partial vacuum is so important, and of course, I have to explain later, that has to do with the Daniel Bernoulli's principle. And in fact, this is one of them. And like I said, anytime I was in the car, I remember for a few seconds you can tell that you are not in control of your car, especially if they pass by so fast. But if they go slow, you don't feel it. The reason why, they are not displacing air. But if you go like 25 kilometers, 30 kilometers, you don't see anything. But if they pass by so fast, they displace the air. So this was another one which was so obvious. Let me post this so you can tell. I used to live in Denver, Colorado, and fall is so beautiful. And then I used to walk my dog and then go for sightseeing and walking and then jogging. And then I saw something important. Push this part up a little bit. See, in fall, Colorado is so colorful, so beautiful. So you can see all kinds of leaves, on the floor. And then one time I remember I was watching that, I realized when the cars are passing by, they are creating vacuum. So what happened? All these leaves are going by the side. Well, in fact, this was also great inspiration for me when I come up with the charges. And if you guys remember, last year I published that it is called positive and negative charges and the theory of separation of charges. And this was also great inspiration for me. So I compared this car is passing by, is like a current, and the leaves are like electrons. These are the electrons, and these are the current. So this is going clockwise, this is counterclockwise. This was also great inspiration for me. So you can see when the car passed by like this, what happened? The leaves are pushed by the side. And sometime in Denver, Colorado, it is so cold and it's so freezing, always they use small sands. And that is happened exactly with the same thing. The larger sands are here and the small sands, are pushed by the sides. So this is so important, and like I said, this shows you when the car is passing by like that, for a few seconds, they're creating vacuum here, and then I was watching so closely, and then I could see this car is even slowing down, the leaves are going toward the car. And that was amazing. And immediately I analyzed that it has to do with the vacuum, so they're creating partial vacuum. And then I remember one time a Lamborghini and Ferrari passed by. And then I realized that is so different. The lower your center of gravity is, like Tesla, Lamborghini, Corvette, and those cars, you displace more. If you're a high-profile car, you displace less. And like I said, this Porsche is displacing more because the center of gravity is low. And then I saw even the car is passing, and the little leaves, well, it depends on the mass, how heavy those things are. They are accelerating toward it. Of course, these are some experiment I did. I said, how could I prove that, they create partial vacuum? So what I did, I had to buy very expensive, sensitive scale, and this scale is amazing. It is 1 microgram. That is so sensitive. And if I have this feather, and then I can weigh this, let me open this up. Well, of course, the bad thing is, unfortunately, you can see it's too small, but I did this so many times. This feather has exactly, let me see how much to 0.754 milligrams, this feather. And one part of the feather, which is a smaller, let me see where that is. I can cut it from here. This part was microgram. And then I said, if I blow on top of this scale, so I can create vacuum. So this scale can be exactly like those cars I show you. When I blow on top of this, what happened? These are factory calibrated, and they are atmospheric pressure, which is 14.69696 psi. And then when I blow on this, I'm creating partial vacuum. And if I turn this on, well, I don't know if you guys can see it. It is showing less. It is showing less mass, because what happened, atmospheric pressure has weight. Even though this is like maybe 6 or 8 or 10 or 16 square, centimeters, but I'm displacing air, and then you can tell us. There's another thing where the Bernoulli'S law is, let me see where that is. I remember I demonstrated this, and this is extremely important law in physics. And you can tell this is exactly like a wings of airplane. And you can see this is called airfoil. It's exactly like birds. And you can see the bottom part is almost flat, but the top part, air takes longer to travel here, but shorter. And it's creating difference of pressure. So Bernoulli says, law, when the liquid, even air we can consider liquid, when it's passing by so fast, the pressure goes low or go, so the high pressure pushes. So imagine that 40-ton airplane can pick up. Without the Bernoulli's laws, there was no way we could fly airplanes. There's another simple thing, let me see if I can demonstrate this. See, if you consider this airplane wings, see how easy we can demonstrate Bernoulli's law. Because now this paper is bent due to gravity, and at the same time atmospheric pressure is here. But see what happened when I blow on this, what's happening? This is exactly like airplane wing. So I'm blowing on it. See what happened? I'm blowing here, I'm creating vacuum, so the air is traveling faster and the atmospheric pressure is pushing on this, so air is going faster here and then is creating low pressure here. And in fact, this is the one I demonstrated a few minutes ago. That piece of paper, which is exactly like Bernoulli's law. See, if you're holding a piece of paper like this, and then you blow on top, so what happened on the bottom? You have high pressure, and lower part is low pressure, and it goes up. And that is the way the bird's been doing for millions of years, and then finally Wright brother found solution and invented the airplane. And in fact, this is so important. Sometimes I remember I have seen some documentaries, old shacks or, old houses in the middle of nowhere, in a, desert or whatever. They have flat roofs, and it's not concrete. It's like plywood, and sometimes, it might be even, like thin, metals or something like that. I have seen when the high winds create low pressure here, so what happened, the roof comes off. Unbelievable how powerful it is. So that roof must be so good, secured with nails and the screws and things like that. But that's what happened. And I'm hoping this Daniel Bernoulli's law will be a good lesson for you guys. And then you can, anytime you're flying with airplane, and anytime you're driving, and then the 18-wheeler or, a smaller or, huge buses are passing by, and you wobble a little bit. So that is exactly what happened. So they are creating vacuum. So next time you go in the street, and if it's fall, you can watch if the cars are passing by, and you can see car is already passed, but the leaves are following. So what happened? They are accelerating toward the lower pressure. So they're going there, they're following the car. So thank you very much for watching, and then if you like these ideas, you can subscribe, and anytime you come up with any questions, like I said, that was my email, bahanda1948@gmail.com. You can email me. I'll be happy to help you. And like I said, all of these are unique experiments. I have never seen in any books or any places like this. And every month I will do more theories. I have already uploaded 42 theories, and this is going to be the 43rd. And next month I will publish more. I have almost 30 more theories, and you'll be excited to see how good they are. And I want your feedback, because this is so important in life. If there is no feedback, there is no improvement. I give you one example. Harmonic oscillation is like a pendulum. But if it's electronic harmonic oscillator, it's like capacitor and inductor. If there is no feedback, the oscillation will stop. So I'm, comparing your feedback like oscillation. If you don't have a feedback for me, I have no idea how good I did this, how well I explained this scientific concept. So I want your feedback, and then if you like this, you can subscribe it, and if you have any question, you let me know, and then I'll be happy to assist you. And thanks you for watching, and appreciate it. And like I said, I love young generation, because the email I received, I knew when I exchanged view with them, I knew most of them are young generation, and that was amazing. University, college, or even high school students. And thank you very much for watching, and appreciate that. Thank you.